Hello students, let's take a look at this good question. Using trigonometric Fourier series, we are expected to find the Fourier series expansion for this waveform. Now the first thing to do is to find the period of the wave. Here to here is not the period. Here to here is not the period. It's not. The period is here to here when it takes to repeat itself. Here to here when the waveform repeats itself. Here to here and so on. So I always like to involve the zero because it makes the proceeding processes or approaches more simpler. So I'll take it from 0 to here, which is 0 to what? 2 pi. So t is equals to what? 2 pi. So knowing t, you determine your frequency, which is omega naught over what? T, which is what? 2 pi on what? 2 pi, which is equals to what? 1. Okay, so now here I'll go ahead and then write my general equation for Fourier series. So f of t is equals to a naught plus summation up to infinity from what? 1. Okay, an cos n omega naught t plus bn sine n omega naught t. So now here omega naught is 1. So f of t is equals to what? A naught plus summation up to infinity n is equals to 1 an cos n omega naught is 1, so nt plus bn sine n t, because omega naught is 1. So now I must find my what? I must find my a naught. So now a naught is equals to 1 over t summation t naught plus t into what? F of what? T dt. So I must find the what? The f of t. Okay. So to find the f of t, here I have triangular waveform. These straight perpendicular lines, they are okay. But the slanted lines, I must find the equation for them. Okay. Alright. So now here I'll use the point. Here the point is what? 0, 0. Here the point is what? Pi a. Pi what? A. Okay. So I'll use the point, okay, points, okay, 0, 0, and what? Pi what? A, okay, 0, 0, and then pi a. All right. So now what I'm going to have is the slope. So slope m is equals to a minus 0 over pi minus 0, which is equals to what? A on pi. Now the equation. So now f of t minus, so you use the first point. Okay, where your line is starting from, where it's what? 0, 0. So the first point here is what? 0, 0. So f of t minus the y component, which is 0, is equals to the slope, which is a on t, or a on pi, into t minus the s component, which is also 0. Okay, so when you do this, you get what? A over what? Pi t. Okay, so now my f of what? T is equals to what? A on what? Pi t. Alright, so this is my f of t. So briefly, let me find my a naught. So now my a naught is equals to 1 over 2 pi into 0 to pi into a over what? Pi what? T dt. So this is equals to a over what? 2 pi squared. Okay, a over 2 pi squared into what? T dt. and here is what? Pi, here is 0. So this is equals to, a over 2 pi squared into t squared over t into what? 0 and then pi. Okay, so now a naught is equals to a over 4 pi squared into t squared into 0 and then what? Pi. So now here a over what? 4 pi squared into pi squared minus 0. Okay, you put in the upper limit first before the lower limit. Okay, so this one is equals to what? A on what? A on 4. So now our a naught is what? A on what? 4. Okay, so now let's continue from here. Okay, so continuing from here, I'll just find my an. Okay, I'll just find my an. So finding my an, I'm going to have an put into the equation. Okay, an put into the equation. All right, so I can just go straight ahead. Okay, an is equals to 2 over what? T into what? T naught into t naught plus what? T into what? F of what? T cos what? nt, or let me write here, omega naught. Okay, t, which is equals to what? 2 over what? T into omega into t naught into what? T naught plus what? T into what? F of t cos what? Omega naught is 1, so what? Nt, d what? dt. Okay. Alright, so now that is your general formula for an. So now here, an is equals to 2 over 2 pi into what? 0 into pi into what? A over what? Pi t into what? Cos what? nt dt, which is equals to a on pi squared. A on pi squared into 0 into what? Pi. Okay, into t cos nt dt. Okay, so now here you use integration by parts, which is what? U integral v minus integral u differentiating u. Okay, here is what? V. Okay, so now here you're going to get an is equals to a on pi squared into you hold t. Okay, t sine nt. Okay, you hold t sine nt over what? N. And then here you're going to have sine. Okay, you're going to have if you differentiate cos, you get what? Sine. And then if you differentiate sine, you will get what? You will get cos. Okay, so what are you going to have? Okay, so first what we will do is that we will integrate this. We will integrate this sine. We will integrate this cos. First, we will differentiate t. If you differentiate t, you get 1. Then we will integrate this cos. You will get what? Sine over sine nt over n. Then we will integrate sine nt over n. That one we will get what? Cos what? Nt over what? N. Okay, but it will be what? So it will be minus sine nt over n. Okay, but what will happen there is that the minus will now become what? Positive. Okay, so I'll have positive cos. What I'll have is that I'm going to have cos nt over n squared. Okay, over n squared. Okay, then now I can bring my limits. Okay, so now this one here I can have if I introduce my limits, I'll have a over what? Pi into here, t out, okay, pi out, okay. So if I bring pi out, what will happen is that I can have pi out. So now I'm going to introduce my limit. Okay, I can have pi out. So if I have pi out, I'll have what? Sine what? Nt. No, I'll have sine n pi over n. Okay, here I can have what? Cos, okay, cos pi out, okay. So I can have plus cos n pi over what? N squared. Okay, then 0 into this one, here becomes 0. If this t is 0, here becomes 0. And then cos 0n, if t is 0, then cos 0n is also 0. Okay, and because it's lower limit, it's subtracting, so I'll have minus. Okay, so this is what I'll get. So now here, an is equals to, you see sine n pi, even if n is 1, sine pi is 0. Even if n is 2, sine 2 pi is 0. Even if n is 3, sine 3 pi is 0. So here becomes 0. So I'll be left with what? I'll be left with a over what? Here is pi squared. A over pi squared, okay, into what? Cos n pi over what? N squared minus 1 over n squared, okay. So basically, I'll be left with this one. A over pi squared. I just want it to be eligible. Cos n pi over what? N squared minus 1 over what? N squared. Now, let's say n is 1. If n is 1, cos pi. What is cos pi? Negative 1. Negative, so it will be negative 1 squared minus what? So it will be negative 1 over n squared minus 1 over n squared. If n is 2, then cos 2 pi. Cos 2 pi is positive 1. So 1 over n squared minus 1 over n squared, it will be 0. If n is 3, cos 3 pi is negative 1. So negative 1 over n squared minus 1 over n squared, okay. Then if cos is 4, it will be what? Positive 1. So 1 over n squared minus 1 over n squared, it will be 0. Now if cos is 5, cos 5 pi is negative 1. So negative 1 over n squared minus 1 over n squared, okay. Then if cos is 6, cos 6 pi is positive 1. So positive 1 over n squared minus 1 over n squared, it will be 0. So now here you can see that an is equals to what? 0 for n equals what? Even numbers. Okay, even numbers. Thus, n is equals to 2, 4, 6. And then an is equals to a over what? Pi squared into minus 1 over what? N squared minus 1 over what? N squared, okay, which is equals to a over what? Pi squared into minus 2 over what? N squared, okay. So an is equals to minus 2a over what? N squared what? Pi squared, okay. So this is what? For n equals what? N equals odd numbers, okay. That's n equals what? 1, 3, 5, okay, and then it continues. Alright, so that's our an. So now, having found our an, we must find what? Our bn, okay. We must also find our bn, okay. So let's see how we can find our bn, okay. How we can find our bn. So we already know that our bn is equals to 2 over t into t, 2 over t into here t naught plus t, okay, t naught plus t into what? F of t into, let me find something and put it under, okay, into sine nt omega naught t, which is equals to 2 over what? T into what? T naught plus what? T into what? F of what? T sine n. Okay, omega naught is 1, so nt dt. So here, Bn is equals to 2 over 2 pi into 0 into pi into a over pi t into sine nt dt, which is equals to 2a over what? 2 pi squared, okay, into 0 into what? T, pi, into what? T sine nt dt. So now here I'm going to get Bn is equals to a over pi squared into 0 into what? Pi t sine nt dt. So now here Bn is equals to the differentiation, okay, which is what? 2a over what? No, not 2a, which is equals to what? A, which is equals to a over what? Pi squared into here, you hold 1, so minus cos what? Nt, okay, so here it will be t, okay, alright, so we are using integration by parts, okay, so it will be t over what? N, alright, and then we're going to have here is going to what? Minus cos again, so minus minus, it will be positive, okay, here is differentiation, so it will be 1, so minus cos nt, then minus cos nt again, minus sine nt, so it will be plus, minus minus will be plus, so sine nt over what? N squared. Please get to know the integration by parts. Okay, so here it will go 0 and then what? Pi. Okay, so here what we're going to get is that you put in the limit. Okay, you're going to get a on what? Pi squared into minus pi. Okay, you have minus pi cos n pi, okay, over n, okay, so here you're going to get plus sine n pi, so sine n pi over what? N squared, okay, over n squared, alright, so and then let's continue, okay, so the next one I have to put in 0. So this for the upper limit. So the next one 0. If you put 0 here, it will become 0. So it goes. This one goes away. Sine 0 n. Sine 0. If t is 0, it will be sine 0 n. Sine 0 is also 0. So this whole part goes away. And even here, okay, sine n pi. If sine n pi, if n is 1, sine what? Pi is what? 0. If n is 2, sine 2 pi is 0. If n is 3, sine 3 pi is 0. So even this one, it will become a over pi squared into minus pi cos n pi over what? N, because this place becomes 0. Okay, so if you simplify further, okay, it will cancel out. So you have minus a over what? Pi, okay, cos what? N pi over what? N. Okay, so this is what? Our Bn. Okay, so we can say that Bn is equals to minus a over what? Pi cos n pi over n. Okay, so this is our Bn. Alright, so knowing our Bn, we can just proceed to find our expansion. So we know that the Fourier series now becomes what? Our A naught, okay, which is what? A on what? 4, okay, plus our an. Okay, so summation up to what? Infinity from what? 1. Okay, so what was my an? Okay, so my an, what I got for an was, I got minus 2a over n squared what? Pi squared. Okay, n squared pi squared. Okay, so n squared pi squared into cos nt, plus, let's say, another summation. N is equals to what? 1. What I got here is minus a over what? Pi cos what? N pi over what? N sine what? Nt. Okay, so this is what I have. So now here I can say that f of what? T is equals to a over what? 4. Here I can bring this minus 2a outside, and then 2a over what? Pi squared can come outside, and then I can have here n is equals to 1 over what? N squared cos what? Nt. Here I can say that minus a over what? Pi into what? Because a and pi, they are constants. Okay, over what? 1 over what? N cos what? N pi. Okay, into what? Sine n what? T. So now I can go for the Fourier series expansion. So here, Fourier series expansion. Okay, so that's my Fourier series. Now let me see about the Fourier series expansion. Okay, so the Fourier series expansion, I'm going to have f of t. I'm going to have f of what? T is equals to a on what? 4 minus 2a on what? 2a into pi. Okay, minus 2a into what? Pi squared. Okay, so here you see that when we did this an, it was defined for only what? For only, I think it was defined for, was it only odd functions? Okay, let's try and get that sheet that we worked on again. Okay, so this is the sheet that we worked on. You see that this one was defined for only what? Odd functions. It was defined for only odd functions, the an. Okay, so now I'll put only the odd functions inside. So here, if I put only the odd functions inside, I'll not bring the summation again because now I'm doing the expansion. Okay, so 1. So 1, then it will become what? Cos what? T. Then what? 3. Okay, it's 3. The next one will be what? 3. So plus 1 over what? 3 squared cos what? 3t. Okay, alright. So then the next one will be what? 1 over what? Let's 5 cos what? 5 what? T. Okay, plus, and then it will go on and on and on and on. Okay, so now the next one is what? Our Bn. The next one is our Bn. Okay, so the Bn, it is going to be what? Minus what? A on what? Pi into the summation that we're going to put inside. Okay, so if you put 1 here, cos what? Cos pi. What is cos pi? Cos pi will actually give us minus 1. Okay, so it will what? Minus 1. So it will be minus sine nt pi. Minus sine nt. Okay, so if we put in 2 cos 2 pi, cos 2 pi is what? Positive 1. Okay, cos 2 pi will be what? Positive 1. Okay, so now let's see, if I put in 1, then if I put in 1, then I'm going to have minus, if I put in 1, cos n, if n is 1, that means that you got cos pi. Cos pi is what? Minus 1. So I'll have minus sine n what? N minus sine what? N is also 1. So minus sine t. Okay, now let me put into cos 2 pi is positive 1. So sine what? 2t. Okay, so I'll have positive 1. So positive 1 over what? 2. Sine n is what? 2. Or n is 2. So sine what? 2t. Okay, so here let me put n into what? 3. 3 is minus. So I'll have minus 1 over what? 3 sine 3 what? T. Okay, so now let me put in 4. Cos 4 pi is positive. So I'll have 1 over 4 sine 4 what? Sine 4t. Okay, and then it will go what? On and on and on like that. Okay, so this is what you get. So this is for the interval 0 less than t less than what? 2 pi. Thank you, class. This is the end of this particular lecture. See you in the next one. Thank you so much.